Hello. I am a little silly person, and I realized that I wasn't recording while I was doing the introduction with the PowerPoint. So that's this video, which is now part 1 of our class of, or episode 7 on reptiles and amphibians. So this is the short intro, and in this class we are going on the transition from water to land animals. So here's in reverse. On the left you have our friends the amphibians, and on the right you have the reptiles. So there's also a lot of confusion about what is which, what is a reptile, what is an amphibian, and that's also what we are going to get settled on this first introduction. So there is actually an area that studies these two together, which is called herpetology, which comes from the word of crawling in Greek. So these are crawling beasties. And the characteristic that they have in common, reptiles and amphibians, is that they are ectothermic tetrapods. Tetrapods means that just like us or birds, they have 4 legs. Tetra, pod is foot. And they developed these legs when they came into the land. And they are ectothermic because they have to do something called thermoregulation. And they are what is called cold-blooded animals. We are warm-blooded, which means that we can regulate our own temperature by ourselves in our metabolism. But reptiles and amphibians can't, just like fish. So they need the outside to be able to rise their temperature. So they need to stand in the sun or in very warm rocks, just like you can see here, to be able to rise their core temperature and not freeze to death. That's why you see so many times lizards standing in rocks in the sun, or like crocodiles sunbathing in BBC, because they are actually rising their body temperature. So they, the amphibians more specifically, and later reptiles, represent this link between being a marine animal, so like the ones we've been studying until now, except for the insects. So the fish were living all in the ocean, and then eventually one of their ancestors, which was probably very similar to these fishes that we saw in last class, the one that had fleshy fins, they developed paws or legs from these fins and then were able to walk on land. So here's an intermediate fossil, and then these first amphibians, the ones that were able to go on land and leave the water space and be able to support their weight on the air, which doesn't support our weight as well as water. Probably you've noticed that you can kind of float in water, but you cannot float in air. And so these had to be very sturdy legs to be able to support their body weight. And there's amphibians. Their name actually means 2 lives. And it comes from this very close link that they have between water and earth. So these are animals that can live in both and need to live in both. So let's see what characteristics they have that make them like this, and how reptiles are that allows them to live only inland. So in amphibians, there's 3 main groups of animals. You have the frogs, and toads in the same. You have salamanders and newts, which are these cuties on the left. And then you have the caecilians, which are these long, legless frogs. So these are all the amphibians that exist. Then for reptiles, you have 4 groups of animals. You have the turtles, and in the case of the turtles, there are some that live only in the ocean, and then it's called kind of a regression. They are reptiles, so they went into earth, into the land, and then their ancestors went back into the water. And then you have lizards, you have crocodiles and caimans and alligators, and then you have the tuatara, which is just one species that lives in New Zealand, and it's a descendant of the closest ancestor between birds and lizards. So it's like a living fossil. And snakes are in the same category as lizards, so they are basically just legless lizards. So now you know which ones are amphibians and which ones are reptiles. So the link of amphibians to the water and the elimination of this link in reptiles is very obvious in their reproduction. So amphibians have eggs that are very similar to fish eggs in the way that they are in the water, and they need to be. They're kind of jelly-like, so they're basically water almost. So they need to be in the water for the baby to grow inside. While the reptiles surpassed this obstacle and stopped being dependent on water to reproduce, and they created something called an egg. So an egg is a little box for your baby, which has the water inside. And inside the egg is everything that the baby needs to survive and all of the moisture that it also needs to develop. So this allowed reptiles to be able to go further and develop in places where there is no water. And the proof that turtles are reptiles is that even though they live in the water, they need to come on land to lay their eggs. So you've probably seen that they come, the mother turtles, and then they dig a hole in the sand and they put their eggs and then go back into the water. And another link that amphibians still have to their a bit closer ancestors, the fish, is that they undergo something called metamorphosis. So this is a process in which between egg and adult, there's an extra step, which is the larva. And and in the case of frogs, the larvae are called tadpoles. So maybe you've seen them. They are in puddles and streams, and they are these little wiggly things. Here they are already developing the back legs. And then eventually these ones are the ones that turn into adults. This is just what happens in fish as well. But then in reptiles and birds and mammals, we don't go through this metamorphosis anymore. So the development is all inside the body of inside either the egg or the body of the mother, and they come out very similar to how they will be when they are adults. They just need to get bigger. One other link of amphibians to their water past is their breathing through their skin. So the skin of amphibians is called naked skin, and it's very permeable, and it's one of their breathing organs. So they have lungs, but their lungs don't work 100%, so they also breathe through their skin, and it needs to be moist so that this exchange can happen with the air. So they need to be close to the water so they can get moisture, and also they secrete a mucus. So that's why sometimes they are a bit slimy when they secrete a lot of this mucus. This is also they can breathe. And however, reptiles have either scales or this hardcore armor like crocodiles do in this image. And this protects them a lot more than the naked skin. But at the same time, it is a bit harder, which means that they need to molt to be able to grow. So you remember that insects also had to do this, and crustaceans. So they need to shed off the previous skin so they can grow, and they have a bigger one underneath. And this means that they grow their whole lives and they can become very big. The biggest snake ever seen was 12 meters long, which is pretty big. It's around 36 feet, I think. It's pretty big. All right, and then we are in the class, we went into the locomotion. So the first introduction to the locomotion was through snakes, and you will then see the task on the next video. But we just did the small introduction with the most common way of snakes moving, which is called the serpentine locomotion. So the snakes do this S, and their head is going front. And this is also called lateral undulation. So the head is always going front, just like we've seen until now on the fish, for example. The head will go front it's got the sense organs, and it's got their protection also, because they can bite a lot, or they can also be venomous. I never remember the difference. And they create these S's, and in each S, the body pushes that S pushes the body front. So they create this S and they go front, S and they go front. And that is our first task, which is on the other video. We are going to create snakes with our arms. And our hand, specifically the fingertips, is going to be the head. So we are going to create these S's with our hand and let the rest of our body follow. But we are creating it on a surface. So you can either find a surface. I have now a table, which makes it easier. Either you create a surface and you slide on that surface, or do it on the floor, on the air, or on the floor. So you're going to create the S's, just like with the video, and letting the rest of the body react and follow, because the first thing is the head, our fingertips. And we try to hide our thumb, because snakes don't have legs. Hide the thumb here. And a snake around. So now feel free to please go into the other video. And I hope you enjoyed. I'll see you in a bit.